Invention of the light bulb is a pivotal moment in the history of technology, and while Thomas Edison is most famously associated with it, several inventors contributed to its development. Here's an overview of its invention, structure, and formation. Invention of the light bulb. Early efforts pre-Edison. Humphrey Davy 1800 created the first electric arc lamp by connecting voltaic batteries to a piece of carbon, producing light. While this wasn't practical for everyday use, it laid the groundwork for future developments. Warren de Lauro 1840 enclosed a platinum filament in a vacuum tube which glowed when electricity passed through it. However, the high cost of platinum made it impractical. Joseph Swan 1850s-1870s developed a more practical vacuum-sealed bulb using carbonized paper filaments, and by 1878 he demonstrated it publicly in England. Thomas Edison's contribution 1879. Refinement and commercialization. Edison is credited with inventing the first commercially viable incandescent light bulb. He improved upon previous designs by using a carbonized bamboo filament and created an effective vacuum within the bulb, allowing it to last much longer. In 1879, Edison successfully demonstrated his bulb, and by 1880 he had developed a longer-lasting version. Structure of a light bulb. Bulb glass envelope. The outer shell, typically made of glass, which protects the inner components from oxygen and other gases that could cause the filament to burn too quickly. It also maintains a vacuum or inert gas environment. Filament. The filament is a thin wire, typically made from tungsten in modern bulbs because of its high melting point. When electricity flows through it, the filament heats up and emits light through a process called incandescence. Inert gas or vacuum. To prevent the filament from oxidizing burning up, the bulb is either vacuum sealed or filled with an inert gas such as argon or nitrogen. In more advanced bulbs, halogen gas is used to increase efficiency and longevity. Base and contact wires. The metal base, often a screw base, allows the bulb to connect to the socket and receive electrical current. Contact wires extend from the filament to the base, allowing electricity to flow into the filament. Support wires. Thin metal wires inside the bulb help support the filament and keep it in place, especially during heating and cooling cycles. Electrical contacts. These are the contact points at the base of the bulb which connect with the power source, completing the circuit when the bulb is screwed into a socket. Formation. How it works. Electric current. When the light bulb is switched on, electricity flows through the filament. Incandescence. As electric current encounters the high resistance of the tungsten filament, the filament heats up to a high temperature, approximately 2,500 to 30 degrees Celsius or 4,500 to 5,400 degrees Fahrenheit. The heat causes the filament to glow, emitting visible light. This process is known as incandescence. Longevity and heat management. In modern bulbs, inert gases like argon or krypton slow down the evaporation of the tungsten filament, extending the life of the bulb. However, incandescent bulbs are not very efficient because much of the energy is released as heat, not light. Evolution beyond incandescent bulbs. With advancements in lighting technology, incandescent bulbs were eventually supplemented and often replaced by fluorescent and LED bulbs, which are far more energy efficient. Key takeaways. Thomas Edison is credited with making the first commercially viable bulb in 1879. The basic structure includes the glass envelope, filament, inert gas or vacuum, base, and electrical contacts. It works by passing electricity through a high-resistance tungsten filament, causing it to glow and emit light. The invention of the bulb revolutionized the way humans live and work, giving rise to modern electric lighting.